Assalamualaikum and salam sejahtera. In this video, we will discuss the techniques of differentiation. Okay, from the my previous videos, okay, explain about the product rule and one more is quotient rule. So in this video, we will discuss about the chain rule. Okay. Chain rule is used to differentiate the composite function. If we have the function yx and in the equal to f function f, and in the function f we have the function gx. Okay, so how we differentiate this type of function? So let's say we have yx equal fu, where u equal gx. Okay, then the dy over dx equal dy over du times du over dx. Okay, this is the formula for the chain rule. Because we let y equal to function of u, after that we differentiate first the function of u. This formula can can make the differentiation easier. Okay, so we will discuss several example. Okay, the first example is here. So fx sama dengan fx equal 3 plus 7. Okay, for this function, this is actually okay. If you already learned the differentiation before, I think most of you already know the differentiation. Okay, so if we look at this function, this can be, we can just differentiate the bracket. Okay, then multiply with the differentiation inside the bracket. Okay, however, I want to show you how we do the differentiation, okay, using the chain rule. Okay, for this example, okay, we can change this example to u power of 10, where u now is 3x plus 7. Okay, so df over dx equal, okay, now our f here, okay, equal u. So we have df over du multiply with the multiply with the du over dx. Okay, if you cannot remember the formula, so if we eliminate this du, we will get the df over dx. Okay, only now we do the function in term of u and x. Okay, now what is df over du? Df over du is from f prime here, so df over du we can find from f equal u power of 10. So f equal u power of 10 is 10 u power of 9. Okay, this one is how we differentiate the bracket. So where is du over dx? Du over dx from the second one. So du over dx is 3. So using the chain rule, okay, we can differentiate the function f. Okay, just substitute the f over du. Df over du is 10 u power of 9. Du over dx is 3. Then we need to substitute back the u. So our u now is 3x plus 7. So 10 3x plus 7 power of 9 times u. So times 3 is 30. Okay. Okay. That one is the uh, more the basic, because I want you to understand the before we consider the more difficult function. I want you to understand the the chain rule first, the formula and how to use the chain rule. Okay, for this example, be careful because we need to choose wisely our u. So for this example, so we can consider this as sin u. Why? Because we can differentiate directly sin u without the any other term, any other multiplication of the angle with any number of any function. So now because we take this function as sin u, so our u now is x power of 5. Okay, using the chain rule, so df over dx equal df over du times du over dx. So df over du is from here, so df over du sin u is cos u, differentiation. So du over dx from here, du over dx is 5x power of 4. Then substitute into this formula, so df over du is cos u. Du over dx is 5, du over dx is 5x power of 4. So substitute back the u, cos, and rearrange. So I will put 5x power of 4 at the front of the function. Okay, 5x power of 4 cos. Then don't forget to substitute by u. U is cos x power of 5. Okay, easy. Okay. This one I will give you the example. So you have to use the chain rule. Okay, chain rule here. Show the formula on how to differentiate. The answer is df over du, df over du, df over dx equal 2x exponent x squared minus 7. Okay, so please try by your own. Okay, how to differentiate this function using the product. Don't use the direct, because I know that all of you, okay, most of you know how to differentiate this directly. Okay, we just differentiate exponent, then we multiply with the differentiation of the power. Okay, but now I want you to try. Okay, use the chain rule. That is actually what we have done. Okay, when we directly use, actually that is the chain rule, but without the formula. Now we back to the basic. Okay, so try use the chain rule formula. Okay. Okay, the next one is sine. Okay, for the sine here, okay, what is the fu? So we can define this as, okay, I will change the square root as 1 power of 2. So I will change this as what u power 1, u power 1 over 2, where my u here is sine x plus 3x. So please choose the u that can make our differentiation easier. So df over dx, now if we use the chain rule, df over du, okay, times du over dx. Okay, what is our df over du? So df over du is 1 over 2 u power negative 1 over 2. So du over dx is differentiate sign is cos x plus 3. Okay, so then substitute into the chain rule formula. So df over du is 1 over 2 u negative 1 over 2. Okay, times du over dx is cos x plus 3. Okay. This one is 1 over 2 u. We substitute back u. U is sine x plus 3x. Okay, negative 1 over 2. Or because the negative 1 over 2, I will change this to the denominator. So 2 square root sine x plus 3x, okay, times with the cos. So cos I put cos x plus 3. Okay, that's the final answer. So you can try for the final example, the example E. So example E, I will just give the answer. So the answer is, okay. What is I think the differentiation of second x tangent x. Let me check. Second x is second x tangent x. The differentiation, yeah. So second x tangent x. So we have the exponent x. Second x tangent x. Okay. No, second x tangent. Second exponent x tangent exponent x. Okay, please be careful about the angle and the exponential. Okay, lastly, okay, last but not least, I have one question that combine all the product rule, quotient rule. Okay, this question. Where for this question, I have no intention to differentiate this question. Okay, I just want to show you what you can do if we want to use the all three rules. Okay, so for example, actually here, okay, for the ln x squared plus 3, we can use the product rule, the chain rule. Okay, so here is also we can use chain rule. Okay, that's all. Okay, however, because of the function at the numerator, okay, is multiplication of two functions or product of two functions, then, okay, first after we not after, so while we use the quotient rule, we need to use the product rule in quotient rule, and we need to use the chain rule in the product rule. Okay, let me put, okay, where is the product rule, because the numerator is the function here. Okay, so we need to use here the product rule. Okay, like that. Okay, then if we look at the function, we have the quotient function. Okay, quotient of the function or division of the function. Then because of this, okay, we need to apply, okay, here we need to apply the quotient rule. Like that. Okay, so how to when we want to use the product rule, when we want to use the chain rule, when we want to use the quotient rule. So first I will consider the quotient rule first, because for the quotient rule we have the uv here. So we have the uv, so let's say we have our fx. So I will use the quotient rule. Okay, u prime v minus uv prime divided by v squared. Okay, where our u now is ln x cubed plus 3, then times square root sine squared x minus x. Okay. Okay, our u then our v now is x squared plus x minus 2. Okay, for the v prime should be no problem. However, for the to calculate, to evaluate to differentiate the u, to find the u prime, we need the product rule. Okay, so u prime equal u prime v plus uv prime. I just use the uv and uv but with different colors. Okay, if you look at any reference book, okay, we need to change the parameter here. The constant here, we the parameter, the function here, not only uv. Maybe we can use a b c d. Okay, because we don't want to confuse which one v, which one u. Okay, or u1, u2. Okay, so this for my example, I will use the different color. Okay, so for the u prime here, okay, we have the uv here. Okay, so our u now, for our product rule, our u now is ln x squared plus 3. Our v now is square root sine squared x minus x. Okay, then after we apply the quotient, the product rule, then we can find the u prime, v prime, substitute finally into the quotient rule. However, to do this, okay, to find the u prime for the product rule, okay, this one we need to consider the chain rule. Okay, like that. Okay, after we consider the chain rule, we can find for the u prime and also v prime. Okay, after that, then u prime and v prime substitute into the product rule. After we get the product rule, we will have the u prime and v prime for the quotient rule. I hope you can understand. However, I already put a remark here. For this type of function, it is advisable to use logarithmic differentiation. But this technique is not in our syllabus. But previously, I teach this kind of function. But yeah, this is not advisable for you to use the combination of the product rule, quotient rule, or chain rule. Okay, what we can do is we use the implicit differentiation. The implicit differentiation, sorry. We use the logarithmic differentiation, where we need to put the ln for the left hand side and the ln for the right hand side, just like this. Yeah. After that, we can because ln will separate this to one term for each. Okay, then we can simply differentiate each term. Okay, so I think that's all for the chain rule. Thank you.